2016 Ford F-350 Lariat. It's a 6.7 Super Duty. Super Duty truck, I mean. Customer complaint is, well, now the interior lights are flashing. But going back, customer complaint is, I guess this last summer, he was driving it. Right now it's what, March? He was driving last summer. And his TPMS light fault would come on like he's got now, TPMS fault. It would come on randomly. His blinkers would flash fast like this. Sometimes it would flash, that's me bumping the wipers here. Sometimes it would flash fast, sometimes it wouldn't. I got his blower fan on max, which doesn't even blow. See it right there. There might have been a couple other issues. So, long story short is, we took it to a dealership somewhere. They wanted to put an HVAC module in it, some other module in it, because all these, you know, modules the dealership thought was failing. What? That's not the case. And the guy even told me, he's like, hey, look, there's something else going on. And the guy is right. Well, the dealership's like, well, we're going to put a BCM in it, a body control module. So they put a body control module in it. And ever since they did that, now the lights are flashing. And the key fob buttons, I know it's kind of dark, unlock and lock, will not work. So now he's got more problems. So now it's our time to turn to look at it. So I'm using factory Ford IDS here. And we'll do a self-test. I've got an idea. Well, first I got to get my VCI to connect. Let me get this connected up here 1 second. All right, I'm back. I had to restart my computer, my VCI. This damn thing's like a strobe light, like at a concert. It's driving me insane. Anyway, so we're going to do read out the continuous memory diagnostic trouble codes using the factory software and the interface. And I'll show you what we got going on here. Let me pause it till it reads them all. So I read them all, everything passed except, let's take note of this, APIM, lost comm with the BCM. That's your accessory, show you here, accessory protocol interface module. You see your buttons up there. Lost comm with global positioning system module, GPS. Which I remember the customer mentioning that. BCM tire pressure monitor system. We saw that light on the dash. Tire pressure monitor system. Tire pressure monitor. It says it's got a right rear alder and a left rear alder sensor failure. This is not a dually truck. Hence, what I'm going to show you next is the U code in the BCM. Initial configuration not complete. Left front tire pressure and right front tire pressure. And instrument cluster lost comm with the BCM. What this dealership did, I believe, is they troubleshot it. They put a BCM in it when it did not need a BCM. We got a bus issue, I believe. And I'll show you why. So, well, we're going to get to that together here in this video. The reason is they put a BCM in it, they programmed it, which I did too. I redid the same thing they did, program module installation. But until you get the key fobs programmed, the tire pressure programmed, it will not stop flashing the lights, interior lights, and that is according to the service data, if you look it up in the SI or service information. So that is why they introduced another problem. Now what I'm going to show you next is the top, well, let me show you something in here quick. Go to live network monitor. We can go in here, and we're going to go to medium speed CAN. We know we have, so high-speed CAN and medium-speed CAN. Let's hit play. It's pinging all the modules. This one's going to go red. And that one is too. So we don't have, actually, this one we don't have. This one we have, trailer module. This should be talking, and that's why that fan's not working. Let's go to the global positioning module. We should be talking to that because that's GPS. And it doesn't. So anyways, Let me go show you in the wiring diagrams next. So that previous screen I showed you, there was high-speed CAN and medium-speed CAN. We have medium-speed CAN issues. So your diagnostic, your data link connector, we get high-speed CAN, it goes to all these modules. I don't care about that. That part's fine. Medium-speed CAN, pin 3 and 11 on the DLC, goes up to your HVAC module. No comm. Goes to G and H. T's off, Y's off that. G and H goes up to the trailer tow module. No comm, and he's having trailer issues. And remember, fan issues for the HVAC. Let's go over here. Some of these modules he has, some of these he doesn't. Tire pressure monitor system. He has it, but no comm. Global positioning has it, no comm. APIM has it, no comm. And look, BCM. We can talk to the BCM, but it has different CAN bus isn't into the BCM, and I'll show you that on another picture. And that's why these modules aren't talking to the BCM. Instrument cluster, iCAN and high-speed CAN, they all go through this gateway, so it can talk to these other modules on the bus. Even though it's not on the medium-speed CAN, it's on iCAN and high-speed CAN, it needs to go through this gateway on the DLC to talk to these modules on the bus. So what I'm going to do now is hook up my auto with the topology to give you a better visualization of what we're looking for. Well, before I pull that up here, while I was pulling up, I guess, show you the stuff in the service data. So the dealership put a new BCM in, and it tells you a minimum of 2 integrated keyless integrated transmitter devices, which is your key fob and your key. Minimum of 2 must be necessary to program and configure it to turn off the interior flashing lights. That's one reason his lights are on. It also talks about hit OK there. Parameter reset, if you have to do that. You have to do the PAT stuff for the keys, the LIN bus, and the CI lock configuration. We did all that. I'm sure they did too, or tried to. But they have other issues. And it says in here somewhere, I have to look again, but it shows you got to reprogram the TPMS sensors. It even shows it in the factory program. Well, I'm sure the dealer tried to do that, except they couldn't read everything. And what I'm looking at here is your bus. Notice this. None of these things are lit up. Green is good. Red means there's codes, which is the same codes we just looked at in Ford IDS. We're using the Autel. Instrument cluster loss common to BCM. APIM loss common to BCM. Global positioning system. BCM tire sensors. Initial configuration not complete. Sorry about the glare here. But if you click on this, actually right here, medium speed CAN. Medium speed CAN. We don't have no comm to any of these. That's that CAN. And notice the BCM is on medium speed CAN and high speed CAN. That's how we can still talk to the BCM. But the HVAC, we have no comm to. That's why it's gray. If I go in there, it's going to be a no comm. And this glare is bad. No comm. Global positioning system, no comm. Trailer module, no comm. Radio transceiver. Some of these modules he may or may not have. I don't know if he has heated steering wheel. Driver seat module. But anyways, this bus is not even online talking at all with these other modules. So we got to fix that. Once we fix this, I believe it's a wiring or it could be a module issue or a connector issue. Once we fix this and restore communication, some of these will come up green, and then we can finish and go back and unmess up what the dealer messed up by putting a BCM in did not need and finish programming the rest of the stuff. Oh, this glare is bad. So we're going to go to bus inspection. We're going to use the oscilloscope within here. We know high speed is good, so I'm going to give you a reference voltage here, or a reference waveform to look at. Pin 6 and 14, high speed. Go with this right here. 2.5 volts going to 3.5, 3 3/4. That's high speed. On the high side, positive. That's high speed. On the low side, negative. 2.5 volts going to 1.5, 1 1/4. That's good. Let's go with this. They call it low speed in here. It doesn't matter what you call it in here, but that's low speed. It's actually medium speed. Before we were just on 6 and 14 high speed. Now we're on medium speed. That's what Ford calls it. I'll tell it's called low speed. It doesn't matter what it is. As long as we're on pins 3 and 11. I'm going to slow this way down. We're on 3 and 11. And look, I got no signal. I just got a flat line on high and low. No signal. I even started the engine, nothing. If I go to high speed, got a signal. You can change your scaling and all that. So yeah, there's no signal there. And this should be the same 2.5 bias voltage going to 3.5 high, 2.5 bias voltage going to, 1.5, 1 1/4 low, roughly around there. But look at that, it's like floating around now with it running. We have we don't even have the right bias voltage, like a connector's unplugged or something. What I think we need to do is get to, because we're scoped right down here at those pins, we need to get to these connectors in here, connector 212 and such, and look at all that. Alright, so we're using multiplex in here. 2 or more signal simultaneously over a single circuit. Sorry, it's getting kind of late. It's like 9:24 at night. Anyways, so there's 2 module communication network. You got high speed and medium speed. We know we have a medium speed issue. Also take note that TPM module is also known as a radio transceiver module. Okay, so we are on there's high speed and medium speed. HVAC module has a term resistor, which I'm going to get into, and the BCM has a term resistor because that's the gateway for high speed and your low speed, or medium speed. Term resistor in HVAC, term resistor in the BCM. And what I'm going to get at is the termination resistance should be 60 ohms with everything unhooked. So, ICANN is for another network we're not worried about. The IPC operates as a gateway for the modules on the infotainment area network. We're not having issues with that. And it tells you term resistor for the gateway, yes. For the medium speed and the high speed, we have medium speed issues. It's a term resistor. The gateway is, or the BCM is 1, and the other one is the HVAC, which is right there. Tells you right there, HVAC. So, network termination. The CAN uses network termination to improve communication reliability. The termination modules are located at both ends. In this case, it's our BCM and our HVAC module. As the network messages are being broadcast in the form of voltage signals, the network signals are stabilized by term resistors. Each termination has an internal 120 ohm resistor, so one in the BCM and one in the HVAC, and they run them in parallel across the positive and negative bus. Yeah, right there it says 120 in parallel. The total network should be 60 ohms. What I'm going to show you next is we're not getting 60 ohms on the one. So, read this real quick. The body control module is the gateway module translating the message on the high speed to the medium speed CAN, vice versa. This allows the message to be distributed throughout both networks. Vehicles equipped with this audio system have ICANN, IPCs, the gateway module for that, translating high speed to the ICANN, vice versa. We're not having issues with that. The BCM and the IPC are the only modules that have this ICANN. We don't care about that. What I'm going to show you is we should be getting 60 ohms. We should be getting 60 ohms across the bus. We should get it 60 ohms across pins 6 and 14 and 3 and 11 with the key off, battery unplugged, and everything. I'm using a breakout box to break all 16 pins out. I'm using my multimeter, Bluetooth for my VCMI and all that good stuff, scope and everything. It's a 4-channel scope with a multimeter, a function generator, and a J-box all built in one. 6 and 14 should be getting 60 ohms. That's the high-speed bus. Now remember, we had no issues with the high-speed bus and we got 60 ohms. Right? Now let's do pins 3 and 11. Now we're on pins 3 and 11. We should still get 60 ohms, but we're not. We're getting 6 ohms, 5.8 ohms. You know, if we had 120 ohms on there, we'd be like, okay, we got one term resistor out because they're in parallel, either the BCM part or the HVAC module. But we have basically just the resistance of the wires. So it tells me it sure acts like something is unplugged. Not just one module, but a connector perhaps, maybe, or a wiring issue. We got to look at that. That's why I don't think it's a module issue. So that is some good data. What we need to do next, I believe, is get to these connectors and go and split the circuit and divide and conquer. All right, so we're going to go to connector 212. 212 is right under there. We're on 3 and 11 still. 212 is this bad boy right there. I just moved it. Look, we got resistance back. Watch it. It's all over. I'm moving it around. There's 60. I'm holding it. Oh, I fixed the truck. Now I move it around. And it went to 38, 35, 32. Oh, I just broke the truck and it came back. All I'm doing is I'm moving this connector right here. Look at that. Let me open that connector up. Take a look at that. That's where our issue's at. We fix that, I think we'll be good. Let's go from there next. Well, it's definitely a loose connection because when I open this all the way up, it splits the circuit in half. Remember I said about divide and conquer. I think I said it in this video. We got 120 ohms because we only got one term resistor. So it wasn't an open circuit, it was loose pin retention in there. I don't see nothing obvious. Let me put this back together and get a look, and look a little closer as well. Before I put this back together, I noticed on this connector, I don't know if somebody's been in there. It looks like it's broken. I don't think nothing chewed on, but the plastic is all beat up. I put it back together, we got 60 ohms. This thing isn't latching all the way. Yeah, it's not latching. I know you can't see it in the dark because all that plastic is broken right there where the latch would be. And it's not holding it together. Nothing wrong with the pins. We're just going to have to zip tie it. I'm moving around. See that? See it jump like crazy. And then I'll clean the pins up, make sure. So I hooked the battery back up. I got my meter out of the DLC down there. And look, we got no flashing lights now inside here. No flashing lights. Let's make sure the HVAC works here. Let's just hook up our scan tool again. Try not to disturb those wires until we fix a permanent repair. Let's look at this vehicle again and scan it. Still no blower motor control. We got to see why. Unless we lost comm again. But our lights aren't flashing. Yeah, we turned it off. It knows it's running. Key on, engine off. I have to finish the configuration anyways, but I want to see here. You know, who knows? I think it moved again. It's pretty sensitive. We got to clean it up and take it apart. Take it apart and clean it. Or not even clean. It's not really dirty. The pin retention. Yeah, so we still don't have comm to it. Let me try that again here. Well, it moved again. I got to fix that connector more. We can see it changing with resistance. And the time I hooked everything back up the batteries, it failed again because it was just when you bump it or touch it, it just sort of truck shakes. It messes with it. I got the oscilloscope hooked back up, and I can move this around watching the scope. And you can see it just changing once in a while. Let me get it to do it here. I'm trying to do this in film. Signal when I move it around. Yeah, you can see those little lines. Oh, come on, focus. Yeah, you see that there? That's me moving it. The truck's recognizing it, but it's not the right square wave. We got to fix that before we get this other stuff. So let me look at that connection a little bit closer. Well, it's getting kind of late. It's like going to be 10:30 soon. Anyways, so you saw on the scope there, well, the topology didn't have communication still, and you saw on the scope when I was moving it, it was coming and going. Well, I went back and unhooked the battery. I'm in pins 3 and 11, and I lose my 60 ohms again. That's why we don't have COM. So if I go to 6 and 14, there's my 60 ohms. 3 and 11, 3 and 11. I lost my 60 ohms. I took that connector apart. I took some stuff apart. Took the back shell, the front of it. I didn't see nothing obvious there, but it is dark on it. I need to look in there closer, and I can jump around those 2 twisted pairs of wires in here. Probably hard to see, but there's 2 twisted pairs because it comes in and out of it. That's what I got. Oh, my Mountain Dew's here finally. Hang on one sec. Alrighty, I got my Mountain Dew. Anyways, so I wonder if we got a short on this bus, because if I unplug this, it goes to 120. And I kept saying an open circuit. Well, if it was actually open, split there, it'd have 120, right? Well, if I plug it in, there, but I would get it to go to 60 once in a while. So I wonder if we have a short on the bus. Let's check that next. We got to figure out a test plan to do that. Shouldn't be too bad. Because when I do wiggle it, that's why we have, once we get the 60 ohms back, figure this out, we're going to have COM. Let's guarantee it. I mean, 1 ohm, come on. That's a short. And I'm moving that crap out of it. So let's just check on each side of the bus. On each side of the connector, I mean. To the bus. For the bus. Well, I definitely think it's a wiring problem. So when I do this down here, I'm moving this wire. I'm moving on the one side here that has 120. Well, I guess it's hard to explain because I didn't show you down there, but I'm moving the one side of the harness. I guess it would be considered the female side. I'm moving this side. The female side. Take it off to get 120, plug it back in here. Let me pause this. Yeah, it's a pain in the ass to film and do this, but anyways, move the female side here, the harness. I got a little bit of movement. Oh, let me get back in there. There's a lot there. A little bit of movement. Let me move the male side. It's a lot more, jumps a lot more. 50, you saw it there. Definitely a wiring issue. And I'm not even moving any modules. It's got to be, I always see wiring issues, and like a short to ground that's picking that up. But where? Obviously under here because I'm moving it. I originally thought it was in this connector, pin retention, but it's not. I don't believe. There's something else going on. I'm not even touching it. I was doing that. There's something shorting or touching in there. I just got to get under there and look some more next. trying to catch this on film for you guys. I reach my hand up way up under the dash and move a wire in a certain way, and I hold it with my fingers. This thing stays at 60 ohms until I let go of it. Let me try it again. I'm going way up under here. I have to pause it. Well, the lights are flashing again. We had 60 ohms on the bus I showed you. I moved the wires out of there. I could get a better access in there. That 60 ohms stayed there, unless it changed again, but we still don't have control. We still don't have our bus issue there. We still have our bus issue, I mean, for 3 and 11. If I kind of tap on this HVAC module, move it. Let me move it here. Let me just tap on it quick, lightly. You can see some noise there. You can see some noise there when I'm doing that. Again, this should be 2.5 going high. Now let's go 2.5 going low. Let's just tap on it. And look at that. We have noise in there. We can check our CAN bus one more time. Or our CAN bus, our termination resistance. We have termination resistance issues. And is it because I'm moving that harness and it's moving the back of that, because it runs over to this HVAC module, and that's what I'm moving? I did another truck where I actually had to run a new wire from the HVAC module over to the DLC there, because it was an open circuit for the bus wiring or loose connection. So we can do that. The next step is we need to pull that HVAC module out, get behind it, move wires around. I don't know if you heard me, there's a bike going by, but get behind it, move wires around, see what we get on the scope, because we are changing our resistance, termination resistance. And remember, the HVAC module is one of the termination resistors in this medium speed CAN network. So we'll get back behind that, move wires around, check it with the scope, And we'll also check continuity from there back to the DLC. That's going to be a different part of the video. It's getting close to 11 o'clock here. So I'll just make this part 1 of the video. And then part 2 will come up soon after.